Hello and welcome to day 37 of the 62-day low-level design course. Today we are going to dive deep into two of the most important principles for building maintainable, scalable and flexible software systems, high cohesion and low coupling. These principles are foundational for designing systems that can evolve smoothly over time without breaking down. By the end of today's lesson, you will understand how to apply these concepts to improve your system's architecture, making it easier to maintain and extend. Let's begin by understanding what we mean by cohesion and coupling. These terms are often used when discussing software design because they help us evaluate how well structured and resilient our code is. First, cohesion refers to the degree to which the elements inside a module, class, or function are closely related to each other. A highly cohesive class has methods and properties that are closely related, all serving a single purpose. For example, a class responsible for managing customer data should focus only on operations related to customer management and not venture into unrelated areas like logging or payment processing. On the other hand, low cohesion means that a class has multiple unrelated responsibilities, making it harder to maintain and understand. For example, a class that handles both customer data and payment processing can lead to confusion and difficulty in making changes. Now, let's talk about coupling. Coupling refers to the dependencies between classes or modules. When classes are highly coupled, they depend heavily on each other. This makes it difficult to modify one class without affecting others. Conversely, low coupling means that classes or modules are independent of each other, reducing the impact of changes. In general, we'll strive to achieve high cohesion and low coupling to create systems that are both understandable and flexible. Now that we understand and what these concepts are, let's explore why they are so important for system design. First, high cohesion brings several benefits. It improves readability. When a class focuses on one responsibility, it's easier for developers to read and understand the code. It makes code easier to maintain. Because a cohesive class is focused on a single task, changes are less likely to affect other parts of the system. It boosts testability. Testing becomes more straightforward because the class has a clear and limited scope, which makes it easier to write unit tests. On the flip side, low cohesion can lead to spaghetti code that is difficult to change and prone to errors. As for low coupling, here's why it's critical. Flexibility. When classes are loosely coupled, we can modify or replace one class without significantly impacting others. This means you can evolve your system with minimal risk. Scalability. Independent modules can be scaled individually without worrying about breaking the entire system. Reduced impact of changes. Low coupling ensures that any change made to one part of the system won't ripple through the entire code base, minimizing unintended side effects. To put it simple, applying both high cohesion and low coupling will lead to cleaner, more maintainable code that can evolve more easily over time. Now that we understand why these principles matter, let's discuss how to achieve high cohesion. The key here is to ensure that a class or module has a single, well-defined responsibility. One of the most effective ways to achieve high cohesion is by following the single responsibility principle. According to SRP, a class should have only one reason to change, meaning it should only be responsible for one task. For example, a class that handles user authentication should not also be responsible for user data or sending notifications. By keeping the responsibilities well defined, you improve the clarity and focus of your code. A common issue that arises in many systems is the creation of God classes, which handle multiple unrelated responsibilities. These classes are often large, difficult to understand, and prone to errors when changes are made. To avoid God classes, we should break down large, multifunctional classes into smaller, more cohesive units, each with a single responsibility. Now let's discuss how to achieve low coupling in your system. Achieving low coupling means reducing the dependencies between classes or modules, so changes to one class won't require changes to the others. One way to achieve low coupling is through dependency injection. Instead of having a class directly create its dependencies, we inject those dependencies into the class, usually through the constructor or a setter method. This decouples the class from the creation of its dependencies, making it more flexible and easier to test. Another important technique is to use interfaces and abstract classes. By defining interfaces for interactions between modules, we allow the modules to interact with each other without knowing the specific implementation details. For example, rather than tightly coupling a class to a specific implementation of a payment processor, we could define a payment method interface, allowing us to swap payment methods without affecting other parts of the system. Finally, adopting an event-driven architecture is another powerful technique for reducing coupling. In an event-driven system, classes communicate by emitting and listening to events rather than by calling each other directly. This allows modules to remain independent and reduce tight interdependencies. Refactoring is an ongoing process and it's crucial for applying high cohesion and low coupling to existing code bases. To reduce coupling, we start by introducing dependency injection, which will eliminate the need for classes to create their own dependencies. We can also refactor our code to use interfaces instead of concrete class dependencies, allowing for more flexibility in swapping implementations without breaking the system. When it comes to improving cohesion, the goal is to ensure that each class has a single, well-defined responsibility. If you find that a class is doing too many things, it's time to split it up into smaller, more cohesive classes. The benefit of this approach is that your classes become more maintainable, easier to understand, and much easier to test. Let's look at some practical examples to see how high cohesion and low coupling work in real-world systems. Take an e-commerce system as an example. To achieve high cohesion, we might have separate classes like product, payment processor, and inventory, each with its own well-defined responsibility. For low coupling, we introduce interfaces like iPayment method. This allows us to swap out the implementation of payment method without affecting the rest of the system. Another example is a library management system. The book class could be responsible solely for book-related tasks, storing book details, managing the loan process, and updating the inventory. Meanwhile, a notification service class can handle sending email notifications, keeping it decoupled from the book management process. This ensures that changes to the notification service don't affect the core logic of the book class. It's time for a practical exercise. In this exercise, you will be working with a sample system that is suffering from both low cohesion and high coupling. Your task is to analyze the system, identify areas where cohesion can be increased and coupling can be reduced, and then refactor the system accordingly. Focus on applying the single responsibility principle to break down large, complex systems. Also apply dependency injection and interfaces to reduce the interdependencies between the system's modules. To wrap up today's lessons, here are the key takeaways. High cohesion ensures that classes have a single responsibility and are focused on a particular task, making them easier to read, maintain, and test. Low coupling ensures that classes are independent and do not have many interdependencies, which allows for flexibility, scalability, and ease of modification. By adhering to these principles, you can design systems that are not only easier to understand but also more adaptable to change, helping you build software that stands the test of time. For your homework, I recommend reading chapters on cohesion and coupling in Clean Code, a handbook of agile software craftsmanship. This will give you a deeper understanding of these principles and how they apply to real-world software development. Additionally, check out the book Design Patterns, Elements of Reusable Object-Oriented Software, where you will find more detailed discussion on dependency injection and cohesion. For your homework assignment, analyze a project you have worked on and identify areas where you can apply these principles. Refactor the system to improve cohesion and reduce coupling and document your changes.